Second question is, water is an amphoteric compound that acts as a good solvent of a polar and ionic compound. Equation 1 shows the water acting as a Bronsted-Lowry acid. Equation 1 is given to you. Identify two conjugate acid pairs of the equation 1. For the first one, acid is given to you H2O and you need to find the conjugate base for that acid. You know that acid is always proton rich and conjugate base of the acid 1 or the acid 2 is 1 proton less than the acid 1. So if acid contain H2O, that one, so obviously its conjugate base would be OH negative, because once acid is converted into conjugate base for the Bronsted-Lowry acid, it should lose one hydrogen, one proton should be lost from the acid. Second is acid 2. Acid 2 is HNO2, so you will write HNO2 and its acid would be NO2 negative, because conjugate base for the acid 2, so that would becomes NO2 only, because base will having less one hydrogen as compared to the acid one. This is a concept of Lowry-Bronsted acid. Second, water behave as a Bronsted-Lowry acid when dissolved with CH3NH2. Explain the availability of CH3NH2 to act as a base. You have to write down the reason with the ability of CH3NH2 to act as a base. It can accept proton because it accepts proton due to presence of lone pair. Presence of lone pair on nitrogen. Write an anionic equation to show water acting as a base with CH3COOH. It means that you have to write down the ionic equation for water and CH3COOH. So you will write CH3COOH plus, it is acting as a base with CH3COOH. So base molecule is OH negative. It's going to make it as CH3COO negative. One proton is lost from CH3COOH and one hydrogen is gained in the OH negative. So it becomes H2O positive. So that is the ionic equation for it. Next is B part. The water ionic product of that water Kw measure the extent of water dissociate. Its equation is already given to you along with its graph. Write an expression for Kw. Kw expression is product of ions that are dissociate in the water. So Kw could be written as product of H positive ion acid times by OH negative ion, the base one. That is the expression for Kw. Use the information from the figure 2.1 to deduce whether the dissociation of water is an endo or exo process. Also explain your answer. Process would be endo because with the increase of temperature, as you can see, while you are increasing the temperature, the concentration of Kw, means the product of H positive ion and OH negative ion, is also increases. So it means that more temperature is added to a system. So definitely the process would be endo. So you can write the answer in a way. With the increase of temperature, product of H positive ions and OH negative ion increases. It means that process is endo. The process is endo and more heat is added to a system. More heat is added to a system. So it would be written as endothermic process. Next is an aqueous solution of pH is 7 at the temperature 30 degree. Use that information in the figure 2.1 to explain why that solution could be considered as alkaline at 30 degrees centigrade. So first of all, you must have to be sure about alkaline, or you can say acidic solution, like how you can show that the solution is alkaline. Solution would be considered as alkaline whenever the concentration of OH negative ion is greater than the concentration of H positive ion, because H positive ion are acting to be acid and OH is alkaline or a basic one. So once concentration of bases is more than the concentration of acid, then definitely it would be considered as alkaline. If you have H positive ion, concentration of H positive ion is greater than OH negative ion, then it would be considered as acid solution or acid solution, yeah, at 30 degree. But if you have OH negative ion solution is greater, concentration is greater than H positive ion, it means that your solution is alkaline or a basic one. You need to show that expression, that thing. So it means that I have to go back to the curve first to check either what is the value of Kw at 30 degrees centigrade from the graph. If you go back to the graph, you can see 30 degree. So let me zoom in, and at 30 degree your value is coming as, that is 30 degree, that point, and that's value seems to be, it's lying over here somehow. So you will count down, it's 30 at 30 degree, its value seems to be 1 1 2 3 4 5 boxes between 1 to 2. So it means that you will divide it by 5, 1 dividing by 5, 0.25, and this value is at the middle of that 2 boxes full, and the third one is at the half. So it means that Kw at 30 degree seems to be 1.50 times by 10 raised to the power of minus 14. That is the value at 30 degree. Once your temperature is 30, your value for that Kw is 1.50. So I just pick up that value. So Kw at 30 degree, that is equals to 1.50 times by 10 raised to the power minus 14. You need to find the concentration of H positive ion along with OH negative ion. So you can find the concentration of H positive ion, that is already given to me. It seems to be, its pH value is 7. So it means that I can write 10 raised to the power minus 7 by using the pH concept. So H positive concentration is 10 raised to the power negative of 6. I can use the expression of Kw now, that is H positive times by OH negative. Kw is given to me, that I calculated from the graph, and it is 1.50 times by 10 raised to the power minus 14. So 1.50 times by 10 raised to the power negative 14 times by H concentration is H positive ion concentration, and 1 times 10 raised to the power negative of 7, and OH seems to be, for example, I marked it as X. So X could be calculated as 1.50 times by 10 raised to the power minus 14 over 1 times by 10 raised to the power minus 7. That will become 1.50 times by 10 raised to the power negative of 7. That is the concentration of OH negative ions. That is 1.50 times by 10 raised to the power negative 7. That's the value that I calculated. Now observe that either OH negative ion concentration is greater or each positive ions concentration is greater. That is H positive and that is OH negative. So I can suggest OH negative concentration is greater than H positive ions concentration. I can compare also. This is 1 times 10 raised to the power negative 7, that is smaller, and that is 1.50 times by 10 raised to the power negative 7, that is bigger. So OH negative ion concentration is greater than H positive ion concentration, so I can suggest it's alkaline. So it's proved. In this way you can show that. Next is C part. The three physical states of water have different standard entropies associated with them. In the table it's already showing to you. Explain the difference in entropy value of the water in liquid state and the water in solid state. Different forms of water and different entropy, standard entropies are given to you. You have to explain like why there is a difference in them whenever they are in the solid state and whenever the water is in liquid state. So you can write the reason. Water in liquid is more, it's 70, and solid it's 48. So it means that in liquid the more randomness as compared to solid one. So you can write there is more disorder of H2O molecules in liquid form, due to which it has large entropy value as compared to water in solid state. Because solid the particles are closely binded, so less randomness, but liquid the particles are far away as compared to solid state, so definitely more randomness, more disorder. And if you want to compare the water in gaseous form, you can see it's more 188.7. It means that gases have maximum disorder, maximum entropy value as compared to solid and liquid. But here he needs to find just only solid and liquid, so that's why you have to explain just only these two ones. Explain why the increase of delta S is much greater in water boils than it melts. It means that you have to compare the boiling point of water and melting point of water with the entropy change. So you can write because more energy is required to more energy is needed to break down bonds to its melting point as compared to boiling point. Because at boiling point you can see the particles just only break the bond, but once it melts it means that it will become a gaseous water vapors. So more energy is required to completely break down the bond as opposed to melting, because as compared to that of a boiling point. So it means that melting requires more energy as compared to the boiling one, because boiling point just only show randomness and melting show the evaporation or the state of matter. The energy changes of water, solid to water liquid is given to use, and use that data to show that melting point of water is 0 degree centigrade. So you need to show that expression. That will become, write down the expression of entropy first, that is delta S is equals to delta of H minus T delta S, that is delta G, Gibbs energy. Gibbs energy is equals to delta S minus T times of entropy change. So entropy change delta G is given to you, means Gibbs energy, that one you can put down, that is 0, which is equals to delta H is positive, enthalpy change, that is 6.03 kilojoule per mole, negative temperature you need to show, times by delta S. So you need to find delta S first. Delta S of that equation could be written as product minus reactant, that is the equation. So you can write delta S of H2O in liquid state, means the product state, minus delta S of H2O in solid state, because product minus reactant. So product value of entropy change is given to you, means the liquid one it's 70.1, so you will use that value over here. So 70.1 negative, the solid one 48.80, so you can write 48. Once you find the difference, your value for the delta S will become 22.1. That is the value for delta S. Then plug back over here, 0 is equals to 6.03 minus T is seems to be find unknown, and delta S is 22.1. Once you subtract your equation as T, that is coming as 6.03 over 22.1, and that will become 273 Kelvin, because you need to find in degrees. So temperature 273 Kelvin is also 0 degree. So it's proof. Calculate the standard cell potential of the zinc cell battery. This is about electrolysis. Here you can see E negative value, potential value is negative, and here is E potential value is positive. It means that here is reduction and here is oxidation. So you can write the E cell value. E cell value would be 0.40, negative of negative 1.22. That is negative because of oxidation, means because of the value, and that negative is because of a formula. So that will become 1.62. 1.62. Next is the zinc cell battery usually operate at the pH value of 11 at the temperature 298 Kelvin. The overall cell potential depending upon OH negative ion concentration. The next equation show the electrode potential of cathode changes with OH negative ions. Calculate the electrode potential at the value of pH 11. So first of all you need to find Kw value. For that, Kw is written as H positive times by OH negative. So OH negative Kw value is always standard, that is 1 times by 10 raised to the power negative of 14. H positive value is given to you at the value of pH negative 11. So at the place of H positive ion concentration, you can write 1 times by 10 raised to the power negative of 3. Sorry, negative of 11 I meant. It's negative of 11, and OH negative ion concentration you can find from that. So OH negative concentration could be written as 10 raised to the power negative 14 over 10 raised to the power negative 11. That would be shifted as a numerator and will become 10 raised to the power negative 3. So it means that OH negative ion concentration is 10 raised to the power negative of 3. Now you need to put down everything in that equation. That will gives you the final answer. E is equals to 0.40 negative 0.059 over the Z value seems to be 2 and log of 1 times by 10 raised to the power negative 3 because OH negative ion concentration, that one, and it is equals to, or you can take the square of it. Yeah, once you solve it you will get the value of E as E is equals to 0.40 negative. Once you solve it 1 times by 10 raised to the power negative 3, then apply a whole square, then apply log over it, that will gives you negative 6. Times it by 0.059 by 2. This negative and this negative will become that negative and that negative will become positive, and you can write E equals 0.40 plus 0.059 by 2 times it by 6. Once you solve it you will get 0.577 volt. That will be the answer. 0.577 volt. Be sure to do right calculation. Apply the square first, then take the log. Don't do these things all together on the calculator in one step because that involve the log function. So once you solve it on the calculator, be sure to find the value of that log part separately, then other part separately. If you do in a single step, that will gives you wrong answer because that will never involve that negative 6. Instead of negative, it will become positive. So once that type of question is given to you, you need to find the log function separately and solve it approximately 1 to 2 times to confirm the answer because that equation involve log function. In that way you can get the answer for that second part.